What if we took every last drop of the Earth's water, oceans, rivers, lakes, all of it, and poured it onto the sun? Let's dive into this cosmic experiment and uncover what kind of chaos might unfold if we took all of Earth's water and splashed it on the sun. Would it sizzle out, shrink, or explode into something unimaginable? The sun, massive, powerful, and the source of all life on Earth. It's easy to think of it as some kind of eternal, all-powerful force in the sky. But did you know that it's actually just a regular star? This huge glowing sphere is made up of around 75% hydrogen, with a bit of helium and traces of heavier elements thrown into the mix as well. And while it may seem like it'll shine forever, the sun is on a set life cycle just like all stars. Right now it's about halfway through its life, with around 5 billion years left before it runs out of fuel. When the sun finally reaches the end of its life, it won't simply disappear. Instead, it will go through a dramatic transformation. As it uses up the last of its hydrogen, it will expand into a red giant, growing so large that it might even swallow up some nearby planets, possibly including Earth. But right now we're in the sun's most stable period, and it's pumping out energy consistently, fueling life on Earth. But what if we threw a curveball into the sun's natural life cycle? Picture us scooping up every last bit of water on Earth, gathering it all in one monumental splash onto the sun. Would it actually have any effect, or would the sun just keep shining, completely unfazed? To set up this cosmic experiment, we'd need a pretty big bucket. In fact, we'd need a container large enough to hold all 326 million cubic miles of water on Earth. If that sounds big, that's because it is. It's roughly equivalent to a distance as wide as the space between Washington DC and Chicago. And if we had to use regular buckets, we'd need about 70 quintillion of them, which is a number with 18 zeros. It's hard to even imagine a number that large, but let's say we managed it. We'd have all of Earth's water gathered and ready to pour on the sun. So here we go, the big splash. Water meets sun and nothing. Yep, nothing significant happens. Maybe the sun throws off a small solar flare, almost like it's shrugging off the attempt, but overall it remains completely unaffected. How could that be? To understand why the sun isn't even fazed by this colossal splash, we need to think about just how massive it is compared to the Earth. The sun is so large that our entire planet could fit inside it over 1 million times. To the sun, all of Earth's water is barely a drop in the bucket. It's like tossing a single drop of water onto a roaring campfire and expecting it to go out. It simply doesn't make a difference. But what if we weren't satisfied and wanted to make sure this experiment really did something to the sun? Let's imagine we somehow found even more water, enough to make a real impact. To have any chance of extinguishing the sun, we'd need around 370 octillion buckets of water. That's a number with 27 zeros. If we could somehow gather this unfathomable amount of water and pour it over the sun, what would happen? This time the sun responds in a way that might surprise us. Instead of cooling down or going out, the sun actually becomes hotter, brighter, and even more intense. How could that be? It's all because of the way the sun burns. Here's the thing, the sun doesn't burn the way a campfire does. Fires on Earth need fuel like wood or gas, and they need oxygen from the air. When you pour water onto a fire, the water cools it down by absorbing heat and suffocates the flames by cutting off their access to oxygen. The fire can't continue to burn without these essentials, but the sun's burning is a completely different kind of reaction called nuclear fusion. Nuclear fusion is one of the most powerful processes in the universe, fueling stars like the sun for billions of years. In the sun's core, hydrogen atoms are fused under immense gravitational pressure, creating helium atoms and releasing vast amounts of heat and light. Nuclear fusion doesn't need oxygen, it only needs hydrogen. So could dumping water, a source of hydrogen, on the sun actually make it burn even brighter? Water's made up of 2 hydrogen atoms and 1 oxygen atom, H2O. By adding water to the sun, we're actually giving it more of what it needs, hydrogen. It's like trying to put out a bonfire by pouring gasoline on it. You're just giving it more fuel to burn. When all that hydrogen from the water meets the sun's intense heat and pressure, it fuels the nuclear fusion process even more. The sun says thank you for the extra fuel and starts shining even brighter. The extra hydrogen also increases the sun's mass, which means its gravity becomes even stronger. This stronger gravity allows it to pull its hydrogen atoms together more tightly, intensifying the fusion reaction even further. As a result, the sun doesn't just get hotter, it expands in size, growing into an even more intense version of itself. This isn't just a little increase in brightness. The sun's new intensity would have serious consequences for the entire solar system. The extra heat and radiation would be felt immediately by the planets, especially Earth. With temperatures soaring, Earth would become an uninhabitable wasteland. Any remaining water on our planet would evaporate instantly, and life as we know it would be impossible. But that's not all. If we kept adding more water, the sun would eventually become so massive that it would collapse under its own gravity. The collapse would trigger a supernova, an enormous explosion that would blast the sun's outer layers out into space. The aftermath of this explosion could even result in the formation of a black hole, a region with such intense gravity that not even light can escape from it. So our experiment to put out the sun wouldn't just fail, it would actually transform the sun into one of the most powerful and destructive objects in the universe. Alright, so clearly pouring water on the sun was a bit of a mistake. Let's press rewind and bring back our usual calm sun, but let's take a moment to think about what all that water meant for Earth. What would happen to our planet if we took away every single drop of water? For starters, Earth would look like an empty, lifeless desert. Every ocean, river and lake would be gone, leaving nothing but dry, cracked basins where water once flowed. The countless species of fish, from the tiniest plankton to the largest whales, would no longer exist. Deep-sea creatures used to living in the high-pressure depths of the ocean wouldn't stand a chance without water. Algae and coral reefs, which are essential for producing much of Earth's oxygen, would also disappear. With them gone, oxygen levels in the atmosphere would drop significantly, making it hard for all life on land to breathe. Imagine needing an oxygen mask just to step outside. The absence of water would also throw Earth's climate into complete chaos. Oceans play a critical role in regulating temperatures, so what happens without them? The planet would essentially become one giant desert with temperatures soaring up to 250 degrees Fahrenheit in some areas. And without water there'd be no rain. Forests, which rely on regular rainfall, would dry up and quickly turn to tinder for wildfires. Animals would be forced to leave their habitats in search of food and water, but they'd find none. Some might think humans could adapt to these desert-like conditions, but without access to water, survival would be nearly impossible. Even desert-dwelling societies rely on limited water sources to survive. In a world with absolutely no water, any resources left would be fiercely contested, and chaos would break out as people scrambled for survival. But without oceans, Earth would also lose a crucial shield against the sun's radiation: cloud cover. With no clouds, the planet would be exposed to the sun's full force, raising temperatures even higher and making conditions on the surface even more unbearable. If there's any tiny hope left, it might lie in the form of icebergs. In this superheated world, icebergs would melt rapidly, providing a brief but limited supply of water. But this relief would be temporary, as the intense heat would soon evaporate any remaining ice. Without oceans, Earth would lose one of its best tools for absorbing CO2, leading to an increase in greenhouse gases and worsening global warming. Life on Earth as we know it would simply be unsustainable. So, what have we learnt from this experiment? Pouring Earth's water on the sun wouldn't put it out, it would actually fuel the sun, making it burn hotter and brighter, and taking all the water from Earth would leave us with a lifeless desert, completely incapable of supporting life. In trying to put out the sun, we'd destroy Earth itself. It's a stark reminder of just how connected everything is in our solar system. What other what-if scenarios are you curious about? Drop them in the comments below and let's keep exploring these wild cosmic questions together. Don't forget to like, share and subscribe for more amazing science explorations.